The basic principle of acceptance sampling can be stated as the relationship between the defective rate of a lot and the likelihood that said lot will be accepted. This relationship can be easily described by the acceptance sampling curve, which shows that as the defective rate increases past about 1 to 2%, the probability of acceptance decreases rapidly. This curve can greatly aid an engineer in determining how high of a defective rate will likely be accepted by the customer. The actual details of a plan of acceptance sampling are a little bit more complicated than simply looking at a graph. There are many factors that can go into testing for acceptance. A basic example would be as follows. A lot of 1,000 items is to be judged for acceptance. To do this, a certain number of items, n, are randomly selected. The n number of items are then tested, and if a certain number of items, c, fail, then the whole lot of 1,000 items is rejected, and if the number of items that fail are less than c, then the whole lot is accepted. One factor that can be of great importance to acceptance sampling is the sample size that is tested. An intuitive choice would be to have a very large sample size, say 25 to 50% of the lot size, so that the test can be statistically more accurate. The problem with having such a large sample size is that in many cases testing is destructive, and with so many items being tested and thus destroyed, the customer will not get the desired number of items. There are also problems with having very small sample sizes, because a sample may not represent the whole lot. Engineers have performed studies to determine the minimum sample size required to be statistically significant. One such study is from Srinivasa Rao et al., which describes acceptance sampling plans for determining the average life of a product in a lot. This study shows that for the probability being held constant, the higher the value of C, the larger the sample size must be. For example, if the probability is 0.75 and C is 10, then the minimum sample size would be around 240. However, if C is 4, then the sample size would be halved. The functions that are presented in this study can be very helpful to an engineer looking to create a plan of acceptance sampling. In conclusion, acceptance sampling can help an engineer in determining whether a customer will accept any given lot.